Okay, so we're moving into new territory here, doing something quite different. We'll eventually relate it back to identities that we've been working on, but for right now, this is brand new stuff. Before we actually get to the lesson, I have to demonstrate one other little thing. Don't write this down. Please don't try to copy this down. Especially don't try to write it on that diagram, because this diagram is for something else, so I don't want you to muck it up. Okay. This is called the unit circle. It's an important concept in trigonometry. We don't explore it all that much in this course, but if in another course you might do a whole unit on it, kind of thing. Like there's a lot to it. It's called the unit circle because notice it has a radius of 1. You see that? How it's going through 1 and -1 and -1 and +1 again? So the radius is 1. So that's why we call it the unit circle. And this is what I can do with the unit circle. So that has a length of 1, and any terminal arm to a point on the edge of the unit circle will have a length of 1 because it's the radius. So that's important. Okay? This point has coordinates. Correct? If this is theta and this is x, the x distance to that point, do we all see that? Right? Then using SOHCAHTOA, what is cosine of theta? Adjacent over hypotenuse, which in this case is, Maddie? X over 1, which means x equals cos theta. And if this length is y, then sine theta is y over the hypotenuse, which is 1, which is y, because it's opposite over hypotenuse. So if the length of x to that point is cos theta and the length of y to that point is sine theta, the coordinates of that point are cos theta, sine theta. So this is an important idea. And you can scale this up to be bigger. If my radius was 2, I'd have a 2 on the bottom, and I would just multiply it. It'd be 2 cos theta, 2 sine theta. Don't worry too much about that if you don't know exactly what I mean. So there's lots that you can do with this. That's all we need it for. We need the coordinates of that point on that circle in order to do a derivation of a new formula that we're about to do. Okay? So we just need that. And it will be true for any point on that circle. I can go to quadrant 2 or quadrant 3, and it will still be true with all the stuff we've done with related angles. It might feel a little weird to do it that way because you think, but that isn't making the same kind of triangle. But again, you would just make the same triangle and you would use related angles and stuff. It would still work, trust me. Okay? So if you have a unit circle, then the radius is 1, and any point on that circle, the coordinates are cos theta, sine theta, where theta is the terminal angle that you rotated to get to that point on the circle. Got that? Okay. You need to know this in order to complete this derivation. By derivation, I mean we're going to derive or we're going to develop a new formula. So you need that in order to label this diagram properly. Okay? Couple of things about this. often we have you derive this on a quiz. So we haven't decided this year, or I haven't decided this year if that's going to happen or not, and it wouldn't be till later anyway. But keep that in mind. Okay, so you would probably have to adding some, like, know how this diagram works, label the diagram, and then know the proof that's coming for the derivation. Okay, so a big part of this derivation is going to have to do with the length of that line. So I'm going to give it a name and call it C. I'm going to give this line here a name. I'm going to call it U, because A and B are already taken. It's equal to 1, because that's a radius of the circle. Do you see that? From here to here is a radius. So U equals 1. And same thing, here to here is a radius. So we'll call that one V. And it's also equal to 1. What is this angle? Maddie? It is A minus B. Very good. And the last thing we need is the coordinates of the 2 points. So this first point is on the edge of the circle, and we rotated by angle B to get there. So this is cos B sine B. And the other point, we rotated by A to get there. So this one is cos A sine A. Which one's A and which one's B is not relevant. Like, it's got to be consistent. If you were doing this on your own, it doesn't really matter where the A and the B are. You'd get things kind of backwards in the formula, but it would still work. Got that? Okay, so our diagram is now labeled, and we're going to pick pieces out of the diagram to plug into some formulas that we're going to use in order to complete the derivation. First formula we're going to use is cosine law. Anybody remember what cosine law is? From grade 10, you learned it. Come on. I'll get you started. C squared equals?
A squared plus B squared.
That's Pythagorean Theorem. What are you talking about? No, just kidding. You're right. It's C squared equals A squared plus B squared, and then?
Something, and then cos A.
Good. Cos C. What's the something? C squared equals A squared plus B squared minus 2AB, very good, times cos C. I'm not going to use A's and B's because we use those for something else in our diagram. I'm going to use C squared equals U squared plus V squared minus 2UV cos A minus B from our diagram. We just did cosine law of that triangle. C squared equals U squared plus V squared minus 2UV times cos of the angle across from the C, which is A minus B. Okay? We know U and V. They're equal to 1. Let's sub them in. If you're asking why are we doing all of this, like I said, we're deriving a new formula. When we get to the end and we have the formula and we start using the formula, then we'll understand where this came from. This is not something that you would be able to figure out on your own without somebody having shown you. Obviously, somebody figured it out for the first time on the planet. Probably many people developed it separately in different areas of the world. But, you know, coming up with this on your own is not an expectation of this class, obviously. But once you've seen it, and you practice it a few times, it's fairly straightforward. Now what do we do? Yep.
Well, you get c squared equals 2 minus 2 cosine.
Good. So we'll just do a bit of simplifying. 1 squared plus 1 squared is 2. 2 times 1 is 2. Cos A minus B. And we're going to leave that one alone for now. Next thing we're going to use is length of a line segment. Now, you got part of cosine law, and cosine law was something you used a lot of in grade 10 and you knew pretty well. Length of a line segment is probably not one you used a lot in grade 10. So I'm less confident that you might be able to come up with it, but does anybody at all have any memory of the length of a line segment formula? There's your hint. It's L equals. From grade 10, when you do analytic geometry and you talk about midpoints of line segments and lengths of line segments and median and altitudes and right bisectors in triangles. Familiar at all? And the shortest distance of a point to a line? No? No luck, eh? Okay, so this one comes from Pythagorean Theorem. It's the square root of x2 minus x1 squared plus y2 minus y1 squared. And it's the length of a line segment between 2 points. So if I have, sorry, let me do that again. If I have 2 points, x2 minus x1 is the distance between those 2 points. y2 minus y1 is the distance between those 2 points. So this is like a triangle. And Pythagorean theorem would tell me that L squared equals the length of the x's squared and the length of the y squared, right? That's where it comes from. That probably felt complicated in grade 10, but it's actually fairly straightforward. If you're not sure about that, I can explain it more later, or you can just memorize the formula. What are the x2 and x1s? They're coordinates of those points. So there are coordinates here. Okay? So, an L is actually C. Now we're doing the length of this line segment, which is C. And like I just said, there's the length of a line segment between 2 points. So what are my cosines? Cos A minus cos B, because the x's are the cos squared, plus sine A minus sine B, because the y's are the b, or the sines, sorry, not the b's, the y's are the sines. Yep.
How do you know whether cos A comes first or cos B comes first?
Would it matter? How do you know if cos A comes first or cos B comes first? Would it matter? 5 minus 3 or 3 minus 5 squared will be the same, won't they? So it doesn't matter. Okay. Now I'm going to square both sides. Again, if you're ever asking yourself, how am I supposed to know to do that? Well, because I just showed you how to what to do, right? You don't have to figure out the steps on your own. You just kind of have to memorize them. Once we go through the whole thing, and you might write it out a couple of times on your own, the steps will start to make sense, and you don't necessarily memorize them. It's just sensible what to do next.
Well, now we have 2c squareds, so do
Okay, that's where we're going with this. So hold that thought. Very good. We're not ready to do that yet, though, okay? So what are we going to do next? What do you think?
expand and
Expand those brackets. You're crazy. We're not going to do something crazy like that, are we? Expand those brackets. What that would be? What? How are we going to do that? Nope. That's exactly what we're going to do. And if you think that that's crazy, this is grade 12, and we do crazier things coming up next, where we do expand fairly large, do fairly large binomial expansions or expand fairly large expressions. I want you to think of this as m minus n all squared, or m plus n all squared. M minus n squared is m squared minus 2mn plus n squared. Again, this is grade 12. That is a formula you should probably know. So you're not actually doing the steps of expanding. We're just going to do this. C squared equals cos squared a minus 2 cos a cos b plus cos squared b. So I expanded it all in one shot. If you're not quite following that, this is the same thing as that. And we can go into it in more detail later if you want to ask me about it. Okay, and the second one is sine squared a minus 2 sine a sine b plus sine squared b. Anybody see what to do next? All that work on identities and nobody knows what to do? Yeah, Ava?
Well, could you not like the cos squared b and the sine squared b? Would that equal 1?
Ah, wait a minute. So what if I wrote it like this? Cos squared a plus sine squared a plus cos squared b plus sine squared b minus 2 cos a cos b minus 2 sine a sine b. Are you trying to tell me that cos squared a plus sine squared a is 1? I thought that was only allowed when we were actually doing identities. No, of course not. You can do that anytime, right? Like that's a fact. Yes, we use it a lot when we're doing identities, but it's still a fact, even though we're not quote unquote doing an identity. So that's exactly right. Very good. So we've got a 1 there and a 1 there. I'm going to factor this at the same time because it's going to just be the right thing to do. Cos A cos B plus sine A sine B. One plus 1 is 2. Okay, and we're done with that one for now. Now what do we do? Go ahead.
Now do we bring the 2 minus 2 cos AB and put it in for c squared?
So this equals c squared. And that equals c squared. Folks, that's the same c squared, right? From that triangle, the length of that line. Same c squared. So therefore, 2 minus 2 cos A minus B equals 2 minus 2 cos A cos B plus sine A sine B. Subtract 2 from both sides. Negative 2 cos A minus B equals negative 2 cos A cos B plus sine A sine B. divide both sides by -2. Formula. It's called the compound angle formula because the angle is compounded or made up of two different angles. So it's a compound. It's made up of more than one thing. Like a chemical compound is made up of more than one chemical, right? So this is a formula you need to now memorize. Yes?
On a test, would we go through like all those steps?
Yep. Okay, so we're going to mainly focus on how to use this formula for now. But there's how it was developed. Can you use this formula to find the formula for cos of A plus B? So we're going to start by rewriting the formula. And then I'm going to give you a minute to see if you can come up with an idea, and then maybe we'll give you a hint or see if anybody can come up with it and see if we can kind of figure this out.
So that's a formula we use, but will you ever give us like a circle that we have to
Yes, possibly, but we'll worry about that later. Okay, so cos of A minus B equals cos A cos B plus sine A sine B. This is just one of 6 that we're about to learn. And then there's 5 more that we'll learn later. So there's a lot of formulas. But formulas used to be hard to memorize. In grade 12, you're not going to find them as bad as it used to be. If you do the homework, you will memorize the formulas just fine. Okay, so how are we going to use this formula to figure out what the formula is for cos of A plus B? I just want to give you a minute to think about that. There's one important insight that we need to get us started. Anybody have any thoughts? Gwyneth?
I don't think this is right, but I was thinking maybe it would be like cos A plus B equals cos A cos B plus like two cos A cos B plus 2 sine A sine B and then
Like go back part way up the proof? Is that kind of what you mean?
I
Or
don't
no?
know, it's wrong. So
Okay.
it doesn't matter.
Anybody else have an idea at all? This is hard. I wouldn't expect you necessarily to have it, so I like that you just try to think of something. What if we do this? How does that help? Can you sub that into the formula? Okay, do it. Seems a little bit weird to let b equal negative b equal the negative of itself, but this is a formula and we just decided to sub something into it. We could use whatever letters we want. If we wanted to change a letter, we could, but because we're going to use a's and b's in the future, it's easier that way. So how did this help? Yep.
Because now on the left side is going to be cos A plus B.
All right. So if we can simplify the right side, then we've got this done. Does anybody see how we can simplify the right side? Possibly using some of the stuff that we were learning yesterday.
Can you put like a negative out?
Well, remember we talked about this. Sometimes you can and sometimes you can't. So what's the rule about that?
With the yeah, and
So cosine, go ahead.
Would it be cos A, cos B minus sin A, sin B?
That's where this is going to go, yes. Cosine is even. So cos of negative theta equals cos theta. And we talked about this using quadrants, and we've talked about this using the graph and all kinds of things. And what about sine theta? Sine is odd. Emergency alert system. That's interesting. Okay. Good timing. So this is cos A, cos B plus sine A, negative sine B. But of course, we want to rewrite this to be cos of A plus B and formula. So that's 2 of the 6 already done. They're similar but different, and 2 of the other ones are kind of like that as well. So there are advantages of them being similar. There's sort of less to memorize, and there are some tricks to memorizing these that we'll talk more about when we see the other ones, which will be tomorrow. But then also it could be bad because you get them mixed up. But I think for the most part it'll be good. Any questions about that? All right, let's figure out how to use them. So you don't have this part of the handout. You can do it on the back, or you can do it on your own paper, whatever you want, obviously. We're going to do 1 in degrees, because I think it'll help us make sense of this before we start working in radians. And then we'll have to, because there's an extra step to it when we're doing radians. So let's just look at what the process looks like first before we introduce radians. So basically where this is going, you can find the exact value of some radian measures, right? Or some degree measures, some angle measures. We do exact value from the triangles or sometimes from a graph. But lots of things you can't find the exact value of. We're adding to what we're able to find the exact value of. And namely, the compound angles allow us to find all the pi by 12s. So now we're going to be able to find exact value of pi by 12 radian measures. What are the 3 measures in degrees that we can find exact value of? The 3 main ones. Katie? In degrees. That's hilarious. Now we're thinking in radians, right? And that's great. We have to convert back. I love it. That's good.
30, 60, and 45?
30 and 45 and 60. I'm just writing them in order. Yep, those are the 3 angle measures in degrees. How can I use 2 of those to make 15?
45 minus 30.
So this is, do you agree this is equal to cos of 45 degrees minus 30 degrees? And doesn't that look like the formulas we were just looking at? So that means this is equal to cos 45 cos 30 plus, because you flip the sign, sine 45 sine 30. Is that correct? So now we evaluate them. Cos 45 is 1 over root 2. Cos 30 is a half. Sine 45 is 1 over root 2. Sine 30 is root 3 over 2. If you thought that was fast, I'm going to show you a trick in a little bit on how you can do it that fast as well, if you can't already. Since we have to do 4 of those in every question, you're going to want to be fast at them. And it's actually kind of funny because we just spent the whole unit kind of learning this stuff and found it really hard. But now I'm going to show you how you can do it really easily. Okay, then we expand. 1 times 1 is 1. Root 2 times 2 is 2 root 2. 1 times root 3 is root 3 over 2 root 2, which is 1 plus root 3 over 2 root 2, and we're done. If you put cos 15 into your calculator, it would not give you that exact answer because that answer has the denominator rationalized, right? So you can't just use your calculator and write down the answer. You have to show the steps, and that's the answer that I want to see on a quiz or a test. Any questions? Here are the steps. Step 1, figure out the angle compound. Step 2, and in radians there's a little bit more to that part. Step 2, expand with the formula. Step 3, evaluate all the ratios. Step 4, simplify. Yes?
Could we not have done 60 minus 45?
You're right, we could have, couldn't we? We could have also done 60 minus 45. We could have done lots of things, in fact. There's lots of other ways that we could have done it. You may have forgotten more about the degrees, but you could find the exact value of 135 and 120. So you could have used those two. There's lots of options. All right, let's do pi by 12. Before we can start with pi by 12, we need to talk about something. So what are the angles now in radians that we can use to find exact values, the equivalent ones to the ones that we were doing before? Katie, you want to give us this one?
Pi by 4, pi by 3, pi by 6.
Okay, so I'm going to write them in this order. Actually, yeah, we could start with pi by 3, pi by 4, and pi by 6. Pi by 3 is 4 pi by 12. Pi by 4 is 3 pi by 12. Pi by 6 is 2 pi by 12. I'm going to add to this list, so leave some space there. How can I use, which of those can I use to get 1 pi by 12? Yep.
4 pi by 12 minus 3 pi by 12.
So this is equal to cos of 4 pi by 12 minus 3 pi by 12. 4 minus 3 is 1. So that's equal to cos of pi by 3 minus pi by 4. Very good. Okay, that was step 1. Step 2, expand with the formula. Step 3, evaluate all the ratios. So these are 1/2, 1 over root 2, plus root 3 over 2, and 1 over root 2. Which is 1 plus root 3 over 2 root 2. Anybody recognize that? Yeah? Where's it from?
It's the same as the other one.
Yeah, it's the same as the other one. Exactly the same. Well, that's not really a coincidence. Pi by 12 is 15. So it should be the same thing. And didn't we say 45 minus 30? Well, couldn't we have used 60 minus 45? And isn't that what that is? Pi by 3 is 60, pi by 4 is 45. So we did use the other one and it worked out the same? Okay, very good. Now, here's what last thing I need to tell you on how to do this, and we're going to do a couple more examples, is these are not the only ones that we can use. We can use multiples of these as well. So, I can use 4 pi by 12, 8 pi by 12, 12 pi by 12, 16 pi by 12, and so on. You can keep going. So any multiple of 4. Now there's a little bit more to this because it's not exactly true that it's any multiple of 4, but that's how this works. Because we have 4 pi by 12, we can go 4, 8, 12, 16, 20, and so on. Does that make sense? So what are the multiples of this one? 3 pi by 12. Sorry, we already did 3 pi by 12. 6 pi by 12. 9 pi by 12. 12 pi by 12. Well, 12 pi by 12 is already there. So we don't need to write that twice. The next one would be 15 pi by 12. And so on. And what about this one? 4 pi by 12. Well, 4 pi by 12 is already there. 4 pi by 12 isn't in the pi by 6 list because 4 pi by 12 is pi by 3. Doesn't really matter where you get the list from or how you come up with it, but you do have to reduce these properly. Do you understand what I'm saying? So if you thought of 4 pi by 12 in the pi by 6 list, it's actually a pi by 3. 6 pi by 12, we already have that. 8 pi by 12, we already have that. 10 pi by 12. 14 pi by 12 is the next one that we don't have yet. Okay. The only other thing about this, folks, is 12 pi by 12 and 6 pi by 12 don't work. Cross them out. And any multiple of pi by 2 will not work. Okay, so again, 18 pi by 12 won't work, 24 pi by 12 won't work, multiples of that won't work. If you don't believe me, try it, and you'll probably quickly see why it doesn't work. But we can use all of these other ones and further on in the list more multiples of them.
Is there multiples of 2, or is it like why don't they work again?
They don't work because they just don't work. Well, if you try to use them in the formula, it's not going to solve properly. I can show you later why, or you could try it yourself and see if you can figure it out. Any multiple of pi by 2 doesn't work. So the only multiples of the special triangle ones work.
Why would you use anything higher up? Like, why would you not just...
Well, what if I asked you to do 29 pi by 12?
Oh, okay.
I guess you'd use 15 plus 14 or something like that. So step 1 is look at the pi by 12 list and see if you can find two things that add or subtract to, like the numerator, 7. Yeah, 3 plus 4 is 12. So 3 pi by 12 plus 4 pi by 12. What's another one?
Can we like take them like 50 pi by 12 minus 8 pi by 12?
You sure can. 15 minus 8 is 7. What's another one?
9 minus 2.
9 minus 2. That's another one. What's another one? 10 minus 3, thank you. There's infinite of them, obviously. Okay, so we keep going, but we won't. If you can use quadrant 1 angles, so the 3 plus 4 is going to be the easiest. I'm going to do a different one. You can do 3 plus 4 if you want and see that we get the same answer. But sometimes you won't be able to use quadrant 1 angles, so I'm going to do that as well to demonstrate what it looks like. So I'm going to try, cos of 9 pi by 12 minus 2 pi by 12 which is cos of 3 pi by 4 minus pi by 6. But if you do something different, then you try that, and we'll compare answers after. Okay, I'm going to share with you the secret of how you do these quickly. Do you want to hear it? There's only 3 answers that you can get when you're doing these. The pi by 4s are always 1 over root 2. Have you noticed this? I hope you noticed this in the last unit. Cos of pi by 4 and sine of pi by 4 are always 1 over root 2. So we just know that one. And then what I do is I memorize one other one. The one I memorize is cos of pi by 3. I happen to know that Mr. Newstetter's is sine of pi by 6, I think is the one that he does. Whatever one you memorize, it doesn't matter. Cos of pi by 3 is a half, which means cos of pi by 6 is the other answer that you can get, which is root 3 over 2. Those are the only answers you can get. And if cos of pi by 3 is a half, that means sine of pi by 3 is the other answer. And then sine of pi by 6, again, is the other answer. So if you know that the pi by 4s is 1 over root 2, and then you know one of these, you can figure out what the other ones are by sort of process of elimination. Do you understand? And if you're doing the homework, I can pretty much guarantee you will memorize these without even trying, because you're going to be doing 4 of them in every question. And you do not want to be drawing the triangle every single time for every single one. If you just memorize cos of pi by 3 is a half, you got it. Okay? So, the only other thing we have to think of is 3 pi by 4 is a quadrant 2 angle. So it's negative 1 over root 2. Because cosine is negative in quadrant 2. Cos pi by 6, as I said, is root 3 over 2. Sine of 3 pi by 4, well, that's positive 1 over root 2, because quadrant 2 still, and sine is positive in quadrant 2. Sine of pi by 6 is a half. Depending on which ones you picked, if you had picked 2 different ones, like 3 plus 4, you might get a swapped order on top. Okay? We picked 9 minus 2, so I got that order. They're the same thing. Order doesn't matter. You don't have to rewrite it. Sometimes writing it 1 minus root 3 is a little bit, I don't know, simpler than negative root 3 plus 1. So often computer software will kind of write it that way, but that doesn't matter. You don't have to rewrite it, but you should be aware that if you are looking at your answer compared to the answer at the bottom of the page or in the solutions, like the numerator might just be flipped, okay? But it's the same thing. Okay, we're going to do one more together. And I'm going to give you a little hint for this one as well. You do not want to do cos of negative 3 pi by 12 minus 2 pi by 12. Yep.
Do we kind of like ignore the negative until we get to the formula?
No. Okay, specifically, you don't want the first one to be negative. You can use subtraction, so the second one can be negative. You're subtracting. Same thing, but you're subtracting. The first one should not be negative. So how do we get negative 5 using our list?
Can we just do 10 pi by 12 minus 15 pi by 12 and it gives us negative 5?
10 minus 15 is negative 5. Very good. We could do that. What's another option?
4 pi by 12 minus 9 pi by 12.
4 minus 9 would work. What's another option?
2 pi by 12 minus 7 pi by 12.
7 pi by 12 is not on our list. So watch for that, because it's got to be on our list. What was the other one I was thinking of? Oh, 3 minus 8. Like, right, there's tons of them. Any of these are going to work. So again, you can pick whichever one you want. I'm going to do 3 minus 8. So Maddie, that's why I was saying you don't ignore it. You have to come up with a difference that gives you the negative. Why were you thinking you could ignore it?
Because it's like the special, I know it's kind of different with the special triangles and things like that. When it was on the other side, we kind of like ignored the like negative until later on.
Until later on, right? Because some people, like there are other ways that you could interpret this question where you kind of do ignore the negative, but I don't want to talk too much about that right now. But because I want to show you this method of doing the question. Okay, so that is cos. Oh, by the way, this is a common mistake. We'll probably talk about it after a learning goal or something, but when you're reducing these, notice I'm reducing it properly. I'm not just saying 8 pi by 12 is pi by 3. Yes, it comes from the pi by 3 list, but specifically it's 2 pi by 3. And that makes a difference because it tells us what quadrant it's in, right? Which is going to make a difference in the positives and negatives. Okay, I want you to go ahead and try this one. I was going to ask about that once we're done. Yep, very good. Yep. Oh, you did something different. So 5 pi by 6 is negative root 3 over 2, not 1/2. Right? The cos and the sine are never the same thing. Okay, so there's the answer. I'll leave that up there. If you didn't get it yet, you're going to have lots of chance to practice these things. So that's coming. Gwyneth, you mentioned that there's a pattern in these answers. Anybody else notice? All 4 answers? There's something kind of similar about them. So here's a tip, folks. They're always like this. All the pi by 12s look like this. A 1 and a root 3 on top, and a 2 root 2 on the bottom. Okay? Sometimes people make mistakes, and on a test they're like, equals 1. I'm like, what? Do you really think cos of pi by 12 equals 1? I thought cos of 0 equaled 1 from the graph. I don't think cos of pi by 12 equals 1. Or like equals 0. No. Cos of pi by 2 equals 0. Not cos of pi by 12. So if you do the homework and you get used to the fact that the answer always looks like this, but the negatives on top are maybe in different places, then on a test you're going to know, wait a minute, I did something wrong because I didn't get the kind of answer I'm supposed to get with the 1 in the root 3 and the 2 root 2. But people who don't do the homework, I'm marking the test, and they're like, equals 5. I'm like, oh my gosh, like no, I can guarantee you it does not equal 5. Okay, so watch for that, be aware of that. These answers all do look very similar. The only other thing is the work has some other kinds of questions. So those first questions are just expand using the formula. Question number 2 is like formula backwards. So we didn't do anything like this, but I think you can figure it out. Question 3 is you're given the angles. So something a little bit different happens in B and C and F. Okay? And then you've got 6 of the pi by 12s down there to do. Notice these are all pi by 12s, right? Now we know how to find exact value of pi by 12. Any questions?